Hey everyone, my name is Venelin, and in this video I'm going to show you a pipeline for loading custom documents for ChatGPT and GPT-4 using LangChain. We're going to start very simple with some loaders, the text loader, then YouTube loader, and then PDF loader. Next, I'm going to show you how you can use the indexes and the embeddings. We're going to have a look at the OpenAI embeddings and Hugging Face embeddings. We're going to look at some vector stores. In our case, we're going to look at Chroma, and then we are going to go over everything together and combine it within a single chain and start to ask questions about a PDF file. Let's get started. If you want to follow along, there will be a link to this GitHub repository. I have a notebook on Google Colab that is already running with these dependencies installed. And we have LangChain, OpenAI library, we have ChromaDB, TikToken, YouTube transcript API, PyTube, and then the unstructured local inference reference. We're going to go through all of these and why we might need them. Then we have these imports, and I'm going to run the watermark extension just to show you the versions of the libraries that we have so far. Okay, so next we are getting this function print response, which is going to essentially wrap the responses from the different models that we have. Next, you need to enter your API key right here from OpenAI. And the next thing is that we are going to get some data that we're going to use within today's video. So the data, if you open up the file explorer right here, is going to be the need to read.txt file, and then we have Andrei Karpathy resume file. I'm going to go over those once we need them. Now I'm going to load the text file here. And this will use the text loader from the LangChain library, and it's going to load the text file right here, which is essentially this essay by Paul Graham called The Need to Read. And in it, you can see that the author is explaining why we need to read and why reading is not just it's not done just for the reading's sake, but there might be greater benefits from that. So let's see how we can use this within the LangChain library. I'm going to use the text loader, and then I'm going to use the text of the essay itself, which is again just a text file. Here is the text file. Just copy it and paste it from the blog post. And to get this text file to work with the LangChain library, we're going to use the simplest possible thing. It is the VectorestoreIndexCreator, and this accepts a list of loaders. In our case, we're going to just pass in the text loader, and it says that it is using the ChromaDB, and then it's not going to persist it. So this is fine just for now. And next we have this query. So why someone in today's world would read? Answer in 3 sentences. So this is essentially a text that we can ask against the text from the essay that we are running with. Let's run this. And I would like to answer to contain the query sources. So the source is the need to read. And then we have a question and an answer. Let me just print the answer for you. And here is the answer. According to TextDaVinci 003, this is not using ChatGPT or GPT-4, but internally it is using TextDaVinci 003. So reading helps to develop writing skills which are necessary for solving complex problems. It also helps to discover new ideas and thoughts. Reading good material also helps improve reading skills. Okay, so you can see that we get a pretty nice summary about the point of the essay in just 3 sentences by asking TextDaVinci 003. One of the great things about LangChain, it is that contains a lot of those loaders, and you can use them in order to load different types of data. If we go to the documentation of LangChain, you can see that on the left you have these indexes and then these document loaders. And these are basically all of the different types of loaders that you can have. So you can see you have Markdown, notebook loaders, Notion database loaders, read the docs, documentation loaders, swag, URL, web, Word documents, YouTube, and Figma, CSVs, a lot of loaders. And of all of those, essentially, the text loader is the simplest one. Let's try, for example, the YouTube loader, which is very interesting. So I'm going to load this YouTube video, which is this one, How to Guess the Most of Our Out of Reading by Alex Hormozy. And this video is very short. It is around 30 seconds. And you can get the information from this video in a form of text using essentially the transcript, which is, yeah, right here. For some reason, it is not loading, but that's all right. So I'm going to use the YouTube loader for that. And I had a typo within the off parameter of the installation of PyTube. Let's see if this works now. Let's use the loader and then load the documents. Hopefully this works. And yeah, it does. So you can see that we have an array of documents, and this is not very pretty, but I'm going to call YT documents, the first one, and then to dict. See if this works. Sorry, it is underscore dict, and then keys. Let's see if this works. So we have page content of the document and then some metadata. Let's check the content of it. So this is essentially the transcript of the YouTube video. You get more out of reading one book. That's great. Then 5 times than out of reading 5 mediocre books if your behavior doesn't change. All right, so this is essentially the transcript of the YouTube video. And again, you can use this as an input to your vector store index and start asking questions about it. The next loader that we are going to use is the unstructured PDF loader. Let's run this and see if it works. So it says that it is doing some unprocessing, and then it says that Detectron 2 is not installed. So it is falling back to partitioning with the fast strategy, whatever that means, but at least let's try if we get some content from that. Okay, so we are getting the PDF pages with just a single page, and you can see that this is the content of the source. So let's see what exactly do we have within this PDF. It is a very old CV or a resume from Andrei Karpathy. It is from 2011, I believe, something like that. So it's more than 10 years old. So it's very outdated, but still we have this PDF, which is just a single page. And if you don't know who Andrei Karpathy is, please go and Google him. So you can see that the guy didn't have much of an experience compared to what he has done until now. But at least from the start, he looked like someone who is very interested in the field of deep learning. Even the transformers from OpenAI like ChatGPT and GPT-4 are bounded by the limit of their tokens that they can take. So in our case, the Andrei Karpathy's resume have 1,434 characters, and Text DaVinci 003 might take just 1,000 characters, or it might be something that you're limited by. So in order to get around this problem, the LangChain library converts or gives these text splitters, and there is a very basic one called character text splitter, and then we have this recursive character text splitter, which is essentially the recommended splitter. And we can go to the documentation again, so this is within the indexes again, text splitters, and then you have a getting started section. which is giving you an example of the recursive text splitter, and then or recursive character text splitter. And then you have the documentation for the recursive character text splitter. And they say right here, this is recommended for generic text. So yeah, this is something that you might want to use in even if you're working with some strange or very unknown text to you. So this is what we are going to do right now. And the first thing that you will see is that you can pass in this chunk size, which is essentially the number of tokens that you can get, or essentially characters, not tokens. And then you have some chunk overlap. Why this might be useful? Well, if you chunk the text within the different batches or different chunks of text, you can essentially create disconnect between the contexts. So you might want to have some overlap between the text so that the context is not lost when you're going to another chunk. And in this case, I'm passing in 64 as a very small overlap between the chunks. And then I'm creating this recursive character text splitter, and then I'm calling the function or method split documents on the PDF pages. And you can see that we have now two texts that are going to contain different number of words or characters. And you can see that the first is actually almost 1,000 characters, while the second one is also almost 500 characters. Let's see what do they contain. And this is the first document and the second document. So the first one starts from the beginning, as you can see, and finishes up until the coursework title. Let's see where this is within the original text. So here it is. So up until somewhere here, this is essentially the first chunk. And then you can see that the coursework is not started within the second chunk, but the second starts within the overlap area, which is 4 consecutive semesters. So this is the one. But you can see that the character splitter is doing a good job of not splitting individual words. So it tries to be within the bounds, but also it is trying to not split individual words into different chunks, which is great. The next part that essentially the VectorestoreIndexCreator is doing is to use embeddings. And in this case, I'm going to load the SentenceTransformers embeddings using the Hugging Face embeddings. I'm going to pass in the model right here. And this should go ahead and download the checkpoint for this model in order for us to use the embeddings from this SentenceTransformers model. Next, I'm going to get just the text of the first page from the Andrei Scarpati resume. I'm going to extract it. So here is the text. This is the first chunk. And then I'm going to call embed documents and see how many embeddings do we get as a result. So we are getting just a single embedding just because we have a one document, but the dimensionality of this embedding is 768. This is so because the sentence embeddings or the sentence transformers from the Hugging Face library is actually using the BERT model as a base model. So this is the dimensionality of the head there. And then let's see what the embeddings contain. It is just a vector with some small numbers, at least in this case. Probably the most popular embeddings are those by the OpenAI embeddings from the LangChain library. And pretty much the interface is the same. You just create the embeddings, and those are using the TextDaVinci 003 model. I believe this is the default and the most recent one. And you can see that essentially the interface is the same, and the number of embeddings or the embedding vector dimensionality is around 2 times or just 2 times of what the sentence transformers have. And when you go through the numbers here, you can see that they're different compared to the sentence transformers. Once that you have your embeddings, you would want to store them for later use. And LangChain provides an interface to a lot of vector stores. So for example, you can use the ChromaDB right here. And the interface is really simple. You need to call from documents, pass in the texts. So these are the text from the recursive text splitter, and then the embeddings. And then you can do similarity search. And this will essentially score how similar the chunks of text that you have right here are compared to the query that you're putting in. And you can see that currently, according to this, the score of the second chunk is actually lower compared to the first chunk on the query, what is the candidate work experience. If you want to have a look at other, let's see, other vector stores, you can go to the docs, and here they have a very nice getting started example. And you can see that this is the Chroma. This is the open source vector store by Chroma. They have some examples here, and they have this FICE, which is essentially a vector database that is provided by Facebook. You can use that as well. And one of the other more popular ones is Pinecone, at least the one that I'm familiar with. And this is essentially a commercial grade vector store that is giving you this storage on the cloud, and you can use this directly within your LangChain library. If you're working with Chroma in particular, you can see that they have on the LangChain library docs, they have this persistence and loading from disk. So how we can do this within the Chroma. So in our case, I'm going to specify this persist directory called db. And now you can see that instead of this without persistence, we are using this duckdb, which is an embedding database or embedded database. We are using it with persistence, and data will be stored in db directory. So this is the directory. It has an index, and these are the files. You can see that we have some bin and pickle files right here. So I'm going to do a similarity search. This should give us essentially the same results that we got above. And I'm going to call this method persist. So this should give you these collections and then embeddings, Parquet files. So now the storage of the contents of the database should be stored on the disk within the db directory. And then just to load this, you need to pass in the embeddings that you have, and then you need to pass in the directory that you're going to work with. And I'm going to do the similarity search, even though I'm not providing any documents. And you can see that even though the results are somewhat different actually within the scores, you can see here, the contents of the file is going to be essentially the same. So now that we have all of the components that the vector store index is providing for us, we can essentially go and replace it using a chain and configure everything that we want on our own. So I'm going to close this side pane here and continue with the retrieval Q&A chain. And in here, I'm going to use the ChromaDB as a retriever within the retriever QA. And then I'm going to use a new model, which is going to be essentially the ChatGPT model. And I'm going to set the temperature to 0. Then I'm going to call this chain with the chain type stuff, which should not remove any of the contents and do not do any summarization or other processing on the data. So let's see how we can run a simple query against the chain and against the data that is provided within the PDF file. So I'm going to ask what is the work experience of the candidate, use no more than 2 sentences. Let's see what ChatGPT is providing us with. And let's print the response. The candidate has worked as a Google research intern developing warning algorithms for video classification tasks and worked on a large-scale warning framework for video analysis. They have also worked as a teaching assistant for various classes. Okay, so this is essentially the summary of the work experience of Andrei Karpathy. And you can see that this is the work experience. of, at least on this resume, developed warning algorithms for video classification tasks and worked on a large-scale warning framework for video analysis, and then some teaching assistant experience right here. So I would say that the summary by the ChatGPT is very much concrete on top of the PDF that we are giving it. Next question is going to be give a background summary of the candidate and then use no more than 3 sentences. This is again running on top of this chain. And the summary is Andrei Karpathy is a PhD student in computer science, or at least he was, at Stanford University studying machine learning and computer vision. He has a master's degree in computer science from the University of British Columbia and a bachelor's degree in computer science and physics from the University of Toronto. He has worked as a teaching assistant and interned at Google Research. So this is essentially the summary of Andrei Karpathy at the point at which he wrote this resume. Very good. And then I'm going to ask a more elaborate question. How likely it is this candidate to be a top-tier deep learning researcher 2 years from now? Use 0 to 10 scale, where 0 is non-existent chance and 10 beyond reasonable doubt. You must choose a number and explain why. So let's see what ChatGPT thinks about this question, which is again very specific to the PDF that we are asking on or working with. Okay. As a language model, I cannot predict this. So, however, based on the candidate's educational background, etc., it seems that they have a strong foundation in machine learning and computer vision. Okay, their experience as a teaching assistant and their coursework in those fields suggests that they have a good understanding of the fundamentals. Okay, so very important. Strong foundation in machine learning and good understanding of the foundations based on the work or the teaching work. Additionally, their work at Google Research and their hacking skills. Interesting. This is from the bottom of the resume. Yeah, you can see this is the hacking skills: Python, C++, MATLAB, Java, Objective-C, etc. Demonstrate that they have practical experience in developing learning algorithms. Based on this information, I would rate their chance of becoming a top-tier deep learning researcher 2 years from now as a 7 out of 10. However, it's important to note that many factors can influence their future success, and this is just a speculative rating. So 7 out of 10, that within 2 years, Andrei Karpathy would have been a top-tier researcher. Of course, he surpassed that by a lot. In this video, we've seen how you can use your own data with the loaders. We've seen how you can use the TextLoader in order to load a simple text file, and then a vector store index that can do the heavy lifting behind the scenes, and then you can query the text file on top of Text DaVinci 003 with some questions or queries that you might have about the text file. Then we've seen another type of loader, the YouTube loader, which essentially loads some transcripts from YouTube, and you can use those to use LangChain with some of the other utilities, and probably you can ask questions on videos or videos information. Next, we've seen how we can load a PDF file, get the contents of it, and then we've explored how we can split the PDF contents into multiple chunks, and then we've used a retrieval Q&A chain with the document itself and ChatGPT in order to start asking questions about the PDF file itself. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to also add to the description of this video. Thank you, and I'll see you in the next one. Bye.